Everybody here intentionally. All right, my name's Zach. I'm a data scientist for Northrop Grumman out of Utah. You're the coworker of Michael, also out of Utah, and we work at Salt Lake City. We'll be presenting today about a knowledge model for data loss prevention. Is the timer running? So our talk today will have two main parts. First, we'll introduce the problem, the need to protect data, how it's protected, and how protected data is identified. And then this project idea that we're building called Dowser, which Michael will give that demo example of. So protecting knowledge is critical to organization's success, whether that's IP, following the law, just there's so many reasons to protect data. And a lot of protection strategies, as they are right now, sort of give guidance at a conceptual level, but then enforcement is at a much more granular token level. And what our project or idea is about is how to bring those two levels together in a knowledge graph. So that disconnect between context and token leads to ambiguity, a lack of consensus, and also sort of no traceability between enforcement and what the policy is. And LLMs, despite all their power, can't really fill that gap because, again, they're trained on the internet. They're not trained on Euro-domain specific data. So Dowser combines classification and a knowledge model to bridge those two levels together. So why protect data? Well, for me, I want to protect my SSN because I don't want to have my identity be stolen. I like having anonymity or right to privacy. There's also a need if that information gives you some competitive advantage, whether that's some magic formula, some data set only I have, or some unique novel method. Those things have value precisely because a limited audience or a limited number of people do. And then the government regulates data as well, which really is our use case. They're very popular. But HIPAA is well known, where health data that is individual is meant to be kept between you and your healthcare provider. And the classification, so we work for a defense contractor and encounter this frequently, where we have to protect data that could damage national security if divulged, which again is a very, very broad scope and definition of what to protect. So how is data protected? Well, the simplest way is just isolate it, whether that means need to know passwords, air-gapped environments. You can encrypt it, you can do continuous scanning to look for any violations, and ideally as well training all of your employees, because without any kind of operational security, every use of data is a single point of failure. But all these methods presume an understanding about what does and doesn't need to be protected, and data in a vacuum is not sensitive or classified. Some association does, like the number 5, okay, cool. But if I say 5 is the radar cross-section of some stealth aircraft, that becomes classified. So some relationship is what makes data sensitive and needs to be protected. So how do we identify data or classify data? Well, the current process that we're trying to improve upon is a SME review. And a SME review works because it's authoritative. They can explain their reasoning and they're accountable if they're wrong, but it's slow and doesn't scale. So you can hard code rules to automate their thought process, but that doesn't scale. It only works for sort of simple pattern matching, and you can never possibly capture all patterns for any given bit of text. So it'll never be all-encompassing. You can train a classifier, and again, there's dozens of software tools that'll tag and identify your data. The problem, though, is you don't even need policy guidance or anything. You just need enough data in any given class to train a classifier. And the biggest issue there is there's no transparency to the policy or the line item in the law, in the guidance, in your company's rules that will tell you why it has that label or not. So ideally, you want to not just classify information, but give some explanation why. So just to clarify, sort of our use case is regular use by good actors, meaning someone who, whether ignorance or neglect, might commit a data spill, or reviews for transferring data across different levels. We're not trying to thwart bad actors, because if somebody wants to hide data in an image, they can, or they can have some fancy cipher that we can't capture. And so our target scope is really text, or things that can be described as text. We do want to eventually do more advanced media, but for now it's kind of just text. So the first thing we do is kind of capture all of that policy guidance, assuming it exists. And this kind of ties back into the example that Neo4j gave at their keynote of modeling a document that is richly structured and gives sort of rules and regulations and definitions. And we want to break that down into just kind of the if X, then Y level of detail. That's the level we chunk it for a RAG application. The problem, though, and where a graph can help, is a lot of times that guidance might say, go look elsewhere in this document, which is pretty useless. Or it might say, go read document X, which no one's a copy of. Or it'll give you caveats that are captured elsewhere. And so you can never capture all words. You can capture all words, but you can't capture all meaning. We also want to kind of pair this to any current protection strategies, such as a dirty word list, which is a list of sort of bad words that may or may not reveal sensitive data, and finding a way to tie those dirty words to line items from your policy guidance gives them a lot of explainability for when you encounter false positives. So a perfect solution is not attainable, but you can greatly improve upon the current manual process of just having all of your data guidance be in some 400-page scanned copy of a PDF. Thanks.
All right, I'm gonna keep going from there. Okay, so far everything's been super conceptual. We've talked about concepts and ideas and how we do things. Now we're gonna jump into a real world example so we can all actually understand what we're talking about. Now, for the real world example, we can't use actual sensitive information that we're trying to protect for obvious reasons. So we are going to use a fake example. And our fake example is that we are a cookie shop. This is pretty topical. If anyone's bored, I recommend you Google Utah cookie wars. It's this whole legislative thing that happened over the last year in Utah where we live. But anyway, okay, so we're a cookie shop in Utah and we've got to protect our sensitive information. What are we protecting? So this represents kind of the guidance that, let's say, our team, our organization has been flowed. So rule number one, you've got to protect the secret sugar cookie recipe. Okay, that's easy, we all understand that. Number two, you've got to protect the knowledge of a new cookie prototype. So these are different. The recipe, everyone knows there is a recipe, they're just not allowed to know what that recipe is. The cookie prototype, I don't even want them to know that there is a cookie prototype. They can't even know that it exists. And then, maybe our chain is trying to franchise into Europe, and now we've got to comply with Europe's GDPR. Okay, so this is these are obviously fake examples, but these are the kind of guidance that organizations get. These are really high level, and they make sense. I understand them. You guys understand them. But once we actually start talking about what they mean, it gets complicated very quickly. So now what we're going to do is we're going to do kind of just like a train of consciousness, and we're going to break these down from these high level things into like individual rules that we can enforce. So just work with me here. I'm going to just go through a bunch of thoughts. So we'll start with the first one. Okay, so we're protecting the recipe, but everybody knows that on the back of a food label, you have to list every ingredient. So obviously I'm not trying to protect the ingredients, that's already public knowledge. However, on my ingredients, one of those ingredients is just natural ingredients, and that actually is a set of spices. Those I am interested in protecting because nobody knows what those are, they just know that they're in the recipe. Also, I care about the amount of each ingredient. They're in order on the label, but I don't know how much of each one I'm using, so got to protect that. These are the specific spices that I care about, so I do want to protect those names. I want to protect the temperatures, times, things like that for like the cooking instructions. Now we're going to the prototype. The cookie is called the Snicker snack, so that's a banned word. Nobody can say Snicker snack. We don't even want that word to get out. It's a snickerdoodle variant, so let's protect snickerdoodle too. It's cinnamon, so don't want to say cinnamon. And inside the company, we don't call it Snicker snack, we just say SNS, so let's block that one too. All right, now we're going to GDPR. I've got to protect personal identifying information, PII. So that's the definition. And then, to be more specific, I'm going to protect name and surname and home address. Obviously, there's way more to GDPR, but let's just pretend that's what I've got to protect. Okay, so now we can see what started as like something that was pretty simple has become quite complicated. Some of these are like positive things that I need to protect. Some of these are negative things that I don't need to protect. It's just a pile of words. But fortunately, this is a knowledge graph conference, so we've got a great way to organize really complicated data structures. So we're going to take all this data and we're going to put it into a knowledge graph. This is our process for how we do that. If you've been going to talks, you've heard like 10 people tell you how to build a knowledge graph. So I won't beleaguer the point, but the way we do it is we build an ontology. That's down there at the bottom, and there's obviously a lot of thought that goes into building an ontology, and you can customize it as much as you like. But the one that we've selected here, we have 4 actors: their source, policy, concept, and context. And we'll like give examples of what those are. But here's our ontology. You can build a pipeline to transform your data into this ontology. That's totally optional, but if your source data, like your guidance documents, if you're expecting them to change, or if there's 1,000 of them, maybe it's worth it to build an automated pipeline. And then you've got to create interfaces so that you can access the data in your knowledge graph. Okay, so we've got our ontology. Let's say we built our pipeline. We flowed the data in. Let's take a look at an interface. This is an internal tool that we have called Astrolabe. It lets you explore the text inside of a knowledge graph. So here we started with source. We've got GDPR and then legal. Then we can sort of build a traversal through the graph. So source specifies policy. These are the policies. There's an error here. The protect knowledge of new cookie recipe is from legal, not from GDPR, if you've been paying attention. And then I can keep building my traversal. So now I can go from policy to concept. So these are the concepts that I'm trying to protect associated with each policy. And now here's my context. So these are like individual terms that are associated with the concepts that I'm trying to protect from the policy. So here's a view that a human can interact with. You can export it, put it in downstream tools or whatever. But this kind of gives me the full picture. At high level, this is what I'm trying to protect, who told me to protect it, how I'm going to protect it, and then what context I'm using to help me protect it. So just this right here is really useful. We can kind of get the full picture in terms of our data protection strategy. All right, so now we've got all the data. That's a big obstacle out of the way. Now we need to actually decide how we're going to protect that data. This is the classification approach, not classification like security classification like, positive, negative sample. So like before we went down the list of kind of what's being done today, all of those are still valid. You can still have an expert review the documents. You can still build like a pattern matching thing to go and look for keywords. With this and the knowledge model that we just looked at really enhances those, and I'll tell you how in a little bit. But this is also a big enabler for large language models. So it talks about LLM and RAG and knowledge graphs where, there were like 10 of them. Everyone's doing it. We're doing it too. Works pretty well. And then, another good thing about having this graph-based knowledge model is that you can do any kind of hybrid approach. So you're free to say, these things are really important. They've got to be manually reviewed. These things I don't care as much. I'm just going to slap like a rule-based model on them. You can plug and play models. You can upgrade them. You can, whatever you want. So that's a major strength here. You're free to choose the classification approach. And now let's talk about that. So there's no reason why we can't put the classification approach or the identification approach right into the same knowledge graph that's holding the rest of the data. So here on the ontology, you can see we've put an identifier node, which identifies the concept. And that identifier, you can see we're showing it in the UI in the bottom. And you can see that we're using a pre-trained model to pick out home addresses and names. This is like a well-studied area. You can go and download one from Spacey or whatever you want to go and find all the names in the document. But now we have a rule-based system to look for all of those cookie prototype names. And then we're using an LLM to try to identify the quantity of ingredients in documents. So that's a little bit more complicated, but that's something that ChatGPT will be able to do for you. So now with this view, again, I can look and I can see for each of my concepts that I want to protect, how am I protecting it? And I've got the short answer. And you can see, oh no, I forgot to protect my bake temperatures. Can't let that information get out. And now as maybe I'm an auditor or maybe I'm like the legal department, I can see, oh shoot, I've got an issue, I need to fix this. All right, so that's the system. We talked about how to make it, what it does. Now let's talk about why it's useful. All right, so at the top level, you have now an explainable, maintainable model of your high-level guidance. So before we just had three items that maybe your low-level engineers don't know what GDPR is and they don't understand the name of the secret cookie prototype because they're new to the company. There's no way they could understand what they're trying to protect. Now we've got all the data, everyone can access it. There's a clear understanding of what it is you're trying to protect and why you're trying to protect it. And this is really, I think this is super important and kind of gets overlooked. The source of data spills, by and large, is people. So if you can educate the people in your organization, you can prevent data spills at their source, and you don't have to worry about, trying to read every document or something like that. You can explore the ontology model, the knowledge graph that we were looking at, much quicker than you can just like hitting Control F in a giant PDF or something like that. And then anytime you have disagreement about the interpretation of a rule, you can have a big discussion, you can pull the right people in the room, and then once you're done, you can update your model. And now that discussion benefits the entire organization because your model is refined and more accurate. You can take the model and you can apply it to traditional classification methods to make them better. So for example, if all I'm doing is like looking for keywords, so like here's my example, I'm looking for the keyword cinnamon. Before, a reviewer might say, hey, you can't say cinnamon, and that's it. Why? Now I have a full string of rationale. Cinnamon is related to the cookie prototype, which is banned for this reason, and here's who said that. Or it might be cinnamon is related to the natural flavors, which is part of my recipe. So either way, now I have like a clear path of like, it's not just, hey, don't say cinnamon. It's like, you said cinnamon, here's why you're not allowed to say it. And now I've got full explainability. Same for a rule-based model. If that's automated, like it doesn't have to be or if it's a reviewer, I have the rationale. If it's automated, I can just, link them to this and be like, here's why you can't say that. For large language models, again, this is what we've been hearing about for the last 2 days. We can use this knowledge graph with RAG to basically inform LLMs and make them much more useful, reduce hallucination, all that good stuff. And then you can still use this as your justification for the LLM output. But it doesn't stop there. So, one of the great things about knowledge graphs is that they're kind of infinitely scalable. You can keep putting different types of data into them and it keeps adding value. All right, so right now we're tracking sources, policies, concepts, contexts, and identifiers. Let's add more data to our graph. Why don't we track content? So like maybe the blog posts or the documents I'm releasing or the emails. Let's track the tags. So like whenever I find something in one of those documents, let's keep track of who wrote the documents, who reviewed them. And now I can start asking some really cool questions. So I can say, hey, who keeps releasing information about recipes? And now I have a short list of everyone who's done it in the last year. And I can look for patterns if I think there's like a bad actor or something like that. I can say, hey, what would happen if we protect a new ingredient? So like maybe, we're using a lot of salt in our cookies and I want to know if we kind of keep that on the down low. Well, now I can see everywhere we use salt or everywhere we talk about salt, I can like forecast the impact of adding that as a protected term. And I can again, like, how do we normally talk about bake temperature? So if someone wants to protect bake temperature, I don't have to just say, yeah, we talk about that a lot. I can pull up examples of all the times we've talked about it and kind of the context around that. So that's expanding the scope. Let's expand it another step. This time we're going to have to kind of drop the cookie shop example. Northrop Grumman is an engineering company in the aerospace and defense sector. So yeah, we don't have any cookies, but we do have things like systems and technical drawings and diagrams, milestones. if we start putting that into the database, we can get to some really, really interesting stuff. So like, for example, if I have a milestone coming up in 2027 and it's tied to these 17 documents, and these 17 documents, refer to these 23 concepts, 22 of which are held at like a high security level, maybe I can use that to inform my staffing over the next 2 years. So I can ramp up the number of people who have clearance to access those documents. I can start doing really impactful kind of business driving work based off of this model. And it pretty much scales, in every direction, because content and documents touch every part of the engineering life cycle. So, I went the wrong way. So let's sum it all back up. Normally right now you have your high level guidance and your low level enforcement, and those two things live in different places and it's hard to link them together. But using a knowledge graph, we can take both of those concepts, combine them in the same place. It really enhances the quality of current identification methods, and it also is a big enabler for kind of the state-of-the-art new ones like LLMs and RAG. And once you've implemented the system, this is really a driver for overall organizational success, because it allows you to comply with regulation. It allows you to be more open and accessible with your information so that you can have better transparency, both with your regulators and customers, and then internally with your employees as well. So that's all we've got. Thank you very much. We're now open for questions.
I cheated and talked to him before, so I'll try to give a little background. So, of course, in cybersecurity, there are commercial tools that you can buy that claim to do data loss prevention, but the thing they don't do is model the use of data in applications. And I wondered if you have applications that come to you, for example, might be at Northrop, might be a CAD application or a PLM product management app, and its use of data is not visible to you, but you need to understand the flow of data exactly in this model. But you need to understand, well, which data is consumed by it or produced by it that needs to be, run through this filter of analysis that you're trying to do there. So I wonder what you're feeling about that. How would you go about that?
I think working in the classification space, going from a low environment to a high environment, meaning like unclassified to secret, that's easy because the NSA is also publicly available, not public, but like there are a lot of scanning tools to make sure you're not going to put some malware up there. Like getting stuff to the high side is super easy. But the problem is it's trapped there. And how do you get data back down? So you're working on a classified project and you need to like send something out to a supplier. How do you take that out of the high side and make sure you're not committing any data spills? So that high to low transfer we're trying to capture here. So you're right that these tools are evaluated for what data they use and manipulate, but these environments are air gapped. Like there is no physical connection from unclassified to classified networks. So it's kind of protected already in that way once it's approved for use. It's really the downgrade is the bottleneck that we're trying to improve upon. Go ahead.
Yeah, and the stuff that you're talking about, like CAD, that's really hard because it's not just like a bunch of words and I just look through the words. Maybe it's a picture or a diagram or like a table. Those are more challenging, but we would like to eventually be able to like handle that type of data too.
Yes, recipe.
We have to stress to our stakeholder, like this is not general optical recognition of a 400-page drawing that's going to identify like things. But if you can like describe, oh, this drawing shows some kind of vulnerability, and then you can tie that to some line item from your policy guidance, like that's kind of the value. Because right now there isn't a way to just like read Cameo and identify whether it's classified or not.
I have a question regarding the kind of conflict in the kind of knowledge graph. For example, like if you use the like a DIN kind of the industrial kind of standard or like ISO standard, then they might kind of conflict each other. Then how you can like solving the conflict in knowledge graph in order to use your kind of framework?
So let me read back. You're saying like, what if there's a conflict in your guidance? Yeah, so that's really hard. And so like what we would say, it's easy to say the right thing. We would say, oh, let's identify the conflict, let's back it up with examples. If we have that model, we can say, this guidance says X, we've derived these concepts in this context. This one says this, we've derived this, these two don't match. Now you have like a really clear case. You should be able to go to the policymakers and say, hey, what's up with this? What do you want us to do? I'm not trying to make the decision. You tell me what you want. That would be like a best case situation, but nothing's perfect. So maybe you would have to kind of rectify them or try to make sure the key stakeholders are happy or something like that. But ideally, it's a tool to help resolve that conflict.
Part of the motivation for this too is finding those disconnects and contradictions, because you'll have one document that might reference 10 others, like this web of guidance. And when there are gaps or contradictions, this is a better way to find those than somebody kind of manually doing a Cartesian product of all possible combinations. So we almost want to find those disconnects to resolve them.
I have one question, because you just mentioned that it's one of your aims to find a contradiction. So I'm wondering what types of reasoning you're using.
The inference part is definitely the harder part. The retrieval is the easy. But if you, like right now, again, we joke that control F is how these documents are read. If I can actually return the most relevant results and find that, oh, reliability is described this way here, but this other way down here, it can sort of more rapidly identify places where the same topic is discussed, but there is a conflict. So we can't automatically adjudicate them, but we can more rapidly identify them, I'd say.
Yeah, when people think about AI, sometimes they think it's magic. Like, yeah, we haven't put a reasoning engine on top of this or anything like that. It would be cool to do that. Maybe we can someday, but right now it's just helps it keep the data organized.
So you protect the information just by querying the way you want it, right? Not in protected, something like that.
Yeah, so there was one slide where we talked about like the identification strategy. So you're like a user of this application is still free to use whatever identification strategy is desired. We did have a process a while ago that was using queries to like identify data, but maybe it wasn't the best approach. There's a lot of ways out there, either to like, rule-based, like regex scanning a document, or an LLM scanning a document. Like there's a lot of good approaches other than just querying.
And I think one thing with this too is we're not trying to replace human in the loop, because if an AI chatbot commits a data spill, then that's like the huge issue. We're just trying to sort of augment or improve that human experience to make the guidance more accessible. Thank you.
I have a couple of online questions. This to people figure out
You're doing something special with cinnamon from the fact that the company mentions every other spice except cinnamon.
Yeah, I think there's lots of ways to kind of like infer stuff about data that's being protected. So that's probably out of the scope of like actually doing the protection. So maybe that would be on the policy guidance writers. If they're really trying to protect their recipe, maybe they should just ban every spice. But that's out of scope of our job. We're just protecting what they tell us to protect.
This is why a lot of classified projects have cover stories that sort of redirect something that seems possible. So you just rename cinnamon to something else.
Another one, how do you capture and maintain the raw data to feed the graph? Capture and maintain the raw data to feed the graph.
So the document we work with is like, well, it's when an update comes out, it's a big deal and everyone's supposed to be aware of it. Like these are things authored by someone in authority. And I think to the extent that the official policy guidance changes, it doesn't change more than once a year. So that hasn't been too much of a concern for us now.
Yeah, but ideally it would be great to get to a point where we can like automatically read stuff in and like analyze deltas and things like that.
Any other questions from the audience? Well, thank you so much. This was awesome.
Thank you, sir.